Here we go. All right, so for those of you who weren't here the other day, we just did like 10, 15, 20-minute lessons on Tuesday. We had time after we went over our final, so I wanted to get us started on stuff. So we talked about angles, we talked about how they're formed by two rays, that they share a vertex. We labeled them, and then we also talked about standard position. We're not really doing this yet today, but in like the next lesson or two in 4.2 or 4.3, we're going to start having all of our angles have one side be on the positive x-axis, the other angle be somewhere in space, and then, or the other ray, excuse me, be somewhere in space, and then the angle is just the area in between those two spots, okay? We'll do a little thing called bearing today, which comes from due north, which is very similar to this, but a little bit different. So we'll kind of do a little bit of these circular angles momentarily, but we talked about standard position. We talked about how degree is a unit of measurement for angles that we already know. We talked about how radians is another unit of measurement. This is our conversion. I fixed this with alpha the other day, but reminder that 180 is equal to 1 pi radians. 180 is equal to 1 pi radian. So when we go between degrees and radians, we're going to use that conversion factor. Pi over 180 is what we multiply by something that's in degrees to get it into radians. And then vice versa, if I'm going from radians and trying to get it into degrees, we're going to multiply by 180 over pi. I use the comparison of degrees Celsius versus degrees Fahrenheit. They still measure the same thing. It's both talking about temperature, but with degrees and radians, we're both talking about angles, but they're two different units of measurement. So that's what we talked about the other day. We also did 3 and 5. So I'll kind of put them up. If you're watching it back on YouTube, you can pause here. We just either multiplied by 180 over pi in order to go from degrees to radians, or we multiplied by, if we multiplied by 180 over pi, we went from radians to degrees. If we're going backwards from degrees to radians, we multiply by pi over 180. Those are something that you need to know how to do for the quiz tomorrow. Going back and forth between degrees and radians. Cool. I bet you probably already knew that, right? If you were to make a guess, you probably would have assumed this was the thing that I was going to ask you on the quiz. Okay, what we're going to still do a little bit more with that today, but we're also going to talk about degrees, minutes, seconds. I don't necessarily think it's harder, but it's a little bit of a different skill and it takes a couple more steps.
And then can you please step back and get laid down real quick?
Here he comes. All right, bye, Max. Okay, so we're going to talk about degrees, minutes, seconds now. So this is another form of measuring angles. I sometimes like to think of degrees in terms of an hour. So think about degrees as an hour, because we are going to talk about how many minutes are in a degree, how many seconds are in a minute, etc. How many minutes are in 1 hour? 60. 60, good. So 1 degree is the same thing as 60 minutes. So that's why I wrote hours next to it, because that helps me kind of get in my mindset with what we're talking about. Similarly, let's think about minutes and seconds. In 1 minute, there are how many seconds? 60 again, good. And then if we're talking about in terms of 1 degree to how many seconds, if there's 60 minutes in an hour and then there's 60 seconds in a minute, how many total minutes are there in 1? 1,000 minutes. It's a lot of minutes. It's going to be not just 60 times 2, it's going to be 60 times 60, which is going to be 3,600 or 3,600. And so those are going to be measurements that we're going to have to know, these guys right here. Basically, degrees, minutes, seconds. Degree is the whole number that will not ever change, but the minutes and the seconds will become a decimal, right? Because if we had like a 30-minute class, what would that be in hours? How much would a 30-minute class be in hours? Half an hour, right? 0.5 of an hour, half of an hour. So we can think of minutes in terms of like a decimal of an hour. So that's what we're essentially going to do here. So on the number 1, we're going to convert from DMS, degrees, minutes, seconds, and put it into just degrees with a decimal behind it. This little 1 dash means minutes. So the first number after the degree is your minutes. And then the 2 little dashes means seconds. In this problem, though, my degree will never change. So that 136 degrees never changes. We are just going to take that 10 minutes and 14 seconds and make it into a decimal. So it's all in degrees. we're gonna do a little bit of conversions today. What's kind of funny is I'm doing conversions with my geometry kids too. Like in this case, we're gonna go from minutes to degrees. So and I don't remember how you've done this before, this is how I always set it up. If I have 10 minutes, and honestly, this little single dash doesn't really mean anything to me, so sometimes I physically write minutes so that I've got my units there. I'm gonna go from minutes to degrees. I'm thinking about, okay, I wanna get rid of the unit of minutes, and I wanna get the unit of degrees. So that means minutes must be in the denominator for me to get rid of minutes, and degrees must be in the numerator. 1 degree is 60 minutes. So I'm gonna divide 10 by 60 in order for my minutes to cancel and for me to get degrees. Now, I know sometimes the science teachers teach it more like this. Ooh, that was way too big of an eraser. Sometimes they teach it more like you're multiplying by this fraction. Or some teachers even just teach you divide by 60. I like you to know why you're dividing by 60, why you're not multiplying by 60 here. So the minutes are gonna cancel, and so we're gonna do 10 divided by 60. And I'm gonna pull my little calculator up so we can use it. 10 divided by 60 is gonna be 0.16667. So we're gonna make that 0.1667. I'm gonna always just round 4 places. That gives me enough numbers that I'm not rounding too closely, but I don't need all of those in the numerators, all those numbers. Okay, now we gotta do the 14 seconds. So we're gonna do the same thing. We're gonna make that 14 seconds into degrees. And if you remember, I actually can still see it on the board. 1 degree is equal to 3,600 seconds. We gotta cancel my units though, so the seconds has to go on bottom and my degrees goes on top. So that means I'm gonna divide 14 by 3,600. And again, I'm gonna get a small decimal, which makes sense because I told you we were gonna get a small decimal over here. So all of these numbers should be decimals. If you're getting whole numbers, we're having a problem. So you want decimals here when we're putting it into decimal degree form. All right, so 14 divided by 3,600 is going to be 0.0038 or 39, I guess, if I'm rounding just to the 4 places, 0039 degrees. All right, the final step is I need to add those 2 decimals together, and they're gonna go in this decimal place. So I'm gonna do 0.0039 plus 0.1667. So my decimal, the 136 has stayed the same this entire time. It was originally part of the problem. My decimal now is 0.1706. So 136.1706 degrees is my answer, exactly.
So just the minutes divided by 60 and then the seconds divided by 3,600.
Very good. Yep, that's it. Can you try the next one without me? Good. I'll leave this on the board for a second if anyone's still copying it, and then I'll join you on the next one. I have some tissues, don't I? All right, I'm jumping to the next one. You can see me do it, follow along. Remember your actual degree, that 93 stays the same, and we just add together the 2 little decimals we got. The decimals I got when I did 16 divided by 60 was 0.2667. And when I did 29 seconds divided by 3,600 seconds, I got 0.0081. And so together I get 93.2748 degrees. How are we feeling so far? Okay, awesome. Okay, now, if you notice, we're doing exactly the opposite now. So now we're gonna go opposite of what we were doing, okay? Now, it's a little bit different. You can't just do exactly everything opposite we did. You can't just multiply by 60, multiply by 3,600. We're gonna take it a little bit part by part. So again, I still am gonna keep my degree the same, so that 103 will not change. We just have to figure out what 0.74 is as a minute and as a second. To start though, we do the opposite of what we just did. We are gonna start by multiplying this 0.74 by 60. So 0.74 is a degree, and we want to get our degrees into minutes. So that means my degree needs to go on the bottom this time. So instead of dividing by 60 minutes, we're going to multiply by 60 minutes so that I get the right units that I want. Our degrees cancel out, and we're going to do 0.74 times 60. Yeah, 44.4 minutes. Are you okay with that so far? That one wasn't too crazy. So 44 is gonna be my minutes. Now, to find my seconds, I'm gonna take the decimal that I just found for the minutes. And how many seconds are in a minute? 60. So we're gonna take this decimal that's now in minutes, so 0.4 minutes, and we're gonna multiply that. 1 minute is 60 seconds. So we're gonna multiply by 60 in order to get that in terms of seconds. So essentially, you're taking the decimal and just multiplying it by 60 twice, but only worrying about the decimal, never bringing the whole number with you.
So you took 44 and left at 0.4. What if there's no, will there always be a decimal?
If there's no decimal, then there's just no seconds. So 0.4 times 60 is 24. If you get a decimal with your seconds, just leave it off. We don't do any part of seconds, just 0.5 of a second is negligible. We don't even need that. All right, can you try letter B without me? All right, got my letter B on the board now. I did 0.77 times 60 and got 46.2, so 46 is my minutes. Then I took 0.2, multiplied that by 60, 12 is my seconds. How are we doing with that so far, exactly? So the decimal form that we have, you have to multiply that by 60 because we're in degrees and we need to get into that. Times 60. Yep. Good question. Then once you get that answer, you get rid of the whole number. The whole number just goes for your minutes, and then your decimal you make into it. Go into seconds. Good question. All right, cool. That is another skill you need to learn for tomorrow. So knowing how to do from degrees to radians, radians to degrees, and now these degrees, minutes, seconds, we're going to use as well. Okay, we're going to practice that one more time though. We got 2 more problems. It says convert to radians on number 4. First thing we need to do is go from DMS to decimal form, and then we can go from decimal form to radians. So we're actually going to practice a lot of skills right here. Okay. Now this one, Zach, you kind of alluded to this a second ago. Sometimes we don't have seconds and that's okay. So we're just going to make this minute into a decimal and we don't have to worry about anything else because we don't have any seconds. So how do I make this 12 minutes into a decimal? 12 minutes, I'm going to do what, Ava? Divide by 60, good. because there are 60 minutes in 1 degree. So we'll get rid of the minutes, divide by 60. Point 2. Again, if we had seconds, we'd have to do the seconds divided by 3,600, but we don't have any this time. So 73.2 is my degree. That is the exact same thing as 73 degrees and 12 minutes. Now, though, we need to convert it into radians. Do you remember what I multiplied by degrees to get into radians? Pi over 180. Pi over 180, good. And I actually want us to put this in the calculator. If you see the directions say calc. So I'm just gonna put that straight in the calculator. I'm gonna go 73.2 times pi. And then I'm gonna divide that by 180. And I get 1.2776. And that's in terms of radians. So we made our minutes into decimal, then we multiplied the decimal degree by pi over 180. And this time I did want us to put it in the calculator, because the directions said calculator, and I got 1.2776 radians. We'll do more with radians for this to make sense. Right now, like last class, they were like, well, what does this mean? I'm like, this is your answer. This is, radians is the exact same as that in a different measurement. So that's what we're finding here. Go ahead and try letter B without me, and I'll join you there in 1 second, okay? All right, I got my degree as a decimal to be 190.3142. So double check to make sure that, if not the exact same, very, very close to what you had. If you rounded a little bit differently, if you just left it at 3.14, that's okay. Now I'm gonna do make it a radian multiplied by pi over 180. Pi divided by 180, and I get 3.3216 radians. All right, how we doing? Good? Good. Oh, yes, Megan.
So, for like this kind of problem, when you're on the second, like, dividing things, ignore the first decimal place.
If you are, I could have a zero there. Is that what you mean?
No, and so, sorry, where the highlighted yellow answer is.
Yep.
So you put the 0.3 there,
Uh-huh.
and then you don't put the 0 from like 0.01.
Oh, no, when I added these two together, so 0.3 plus 0.0142, that 3 fills in the place for the 0. Good question. Good question. Right, we doing okay? All right, cool. Those are two of the biggest skills that we're gonna do on the quiz. We got a couple more that we've got. Go ahead and flip your paper over. This is, C and D are still a carryover from number 5 where it said convert from radians to degrees. How did we go from radians to degrees again? 180 over pi, very good. I know these two numbers don't have pi in them, but we're still gonna multiply by 180 over pi. You can write your answer with pi in them or write them as a decimal. I'm gonna do both. So we're gonna do those right now. Multiply 3 by 180 over pi. All right, if I make that a decimal, it's about 177.89 degrees. 171, sorry, what did I say, 179? I'm so sorry, Which I actually like the decimal version of this a little bit better because to me, 540 over pi means nothing, but 171 means a little bit more, so. I'm gonna do that and I'm gonna jump over to 1.6 and multiply that by 180 over pi. And that's approximately 91.67 degrees. Cool. Nice, you guys are doing great. All right, the next big thing that we're gonna learn, that we're gonna talk about before this, for this quiz, is something called arc length. Now, it had the word arc length up here, but my problems are on this other page, so I'm just gonna put my little notes for arc length over here off to the side. So this is arc length problems. Arc length is essentially like the crust of a piece of pizza or the crust of a pie. So if I'm looking at like a circle and I have a piece of pie or a piece of pizza in here, I go like a radius to the middle of the circle and then a radius to the other side of the circle. There's a piece of pizza. The arc length is that crust around it. It's essentially like a fraction of the circumference. It's a part of the circumference. You can't measure it like we do straight lines. You can't use like distance formula. You can't use Pythagorean theorem. Like we have to use a special arc length formula because it's a curved distance. So it's not the exact same thing as like going from one point to another. It's not a straight line, it's a curved line, so it's a little bit different. My arc length formula looks like this. It's S equals theta R. S equals theta R. Now, the easiest variable there is R. What do you think R stands for? Radius. Very good. Do you remember what theta symbolizes? An angle. Very good. Now, however, it's not just any angle or any measurement. It's an angle in radians. So if I give you a degree measure, you need to make that degree measure into radians in order to use it. It's an angle in radians. And then S is just the variable we use for the arc length. So we only have 3 things. I'm going to give you 2 of them. You just have to find the third one, okay? Anybody questions on that formula? Okay, let's use it. This problem says, I'll get rid of the calculator for now. It says a 100-degree arc of a circle has a length of 7 centimeters. What's the radius of the circle? Okay, let's draw a quick picture with this. So I've got this little diagram right here, something like that. What does 100 refer to? It's not the arc length. It's the angle. It's the arc angle. So we're going to put 100 in here at the edge of the pie piece. What actually is the arc length? I actually know that one. 7. Good. And what am I looking for here? Radius. Very good. I don't know my R. I don't know my radius. Okay. So if I were to look at my formula, I have 7. I have my S. I have my theta, but I can't use it yet. I gotta do a little manipulating in order to use it. And then I wanna find my R. The only manipulating I need to do is make that 100 into radians. Do you remember how do we make that 100 degrees into radians? Pi over 180, good, pi over 180. I'm gonna do a little simplifying. I really encourage you to not make it a decimal yet. So I get rid of both my zeros so that I can cancel a 10 out of both, and then 10 and 18 both have a common factor of 2, is that it? Okay, so 5 and 9. So this is the same thing as 5 pi over 9. As much as we wanted and would rather use 100, we have to put 5 pi over 9 in for my theta. It must be in radians. All right, how do I solve for R now? I could divide by what? By pi over 9. What's a better way of saying that we're gonna divide by it? Multiply by the reciprocal, multiply by the reciprocal. It's the same thing as dividing, but it gives me a little bit more to work with here. So 9 over 5 pi is gonna get rid of my 9, it's gonna get rid of my 5 pi, it's gonna get my R by itself. You can leave it as a fraction, 63 over 5 pi equals R, or we can make it a decimal, which I actually do want to do to kind of make sure you don't make the same mistake I did. In alpha yesterday, I wrote 63 divided 5 pi. Okay, when I press enter on that though, it says 39.58. Do you know what I should have done differently? I should put parentheses around it. Remember that your calculator is not as smart as we are. It doesn't know that it's 63 divided by both 5 and pi. What it does in here is it does 63 divided by 5, and then it takes that number and then multiplies it by pi. So if you want to do it this way, make sure you do 63 divided by parentheses 5 pi. That will be our right answer. Yes, that.
I don't know what it's called, like, what's that, radical?
Makes it 5. That's
Yeah.
pi.
Why'd you put that there, and not just like,
Why did I put 5 here or pi here next to the 5?
just above that,
Oh,
like in the original, like,
right here.
yeah, why'd you put the radical next to it?
Oh, that's not a radical, that's an R.
Nah.
I know he kind of looks like a radical, that's just an R.
That's so, okay. That's an R the whole time, okay.
Yeah, sorry, I guess my R's a little curly. Let me make them curlier.
Okay,
At first, when you were like, why is he talking about radicals? I was like, that's a pi.
Yeah, we get that.
We were both not good there for a minute, though. Okay, that makes it, yes, that's just an R. So use the variable R, and if you don't like the R, you can use an X. I do not care, but it's about 4.01, and I think my units are in centimeters. So my radius is 4.01 centimeters. All right, the math there isn't hard. The biggest thing that's I think difficult about this is you need to make sure to put it in radians, okay? Let's go ahead and look at the next one. It says, what's the perimeter of a 10-degree sector cut from a circular disc with radius 11 inches? What are you looking for this time?
S.
S. We're looking for S. We gotta find that arc length. What do you need to do before we just plug and chug? We gotta change that 10 degrees into a radian measurement. So 10 degrees, just like we did before, we're multiplying it by pi over 180. This is an easy simplify. The 10 cancels, so I get pi over 18. And then we're going to say S equals pi over 18 times R, which was 11. I'm going to just put this in the calculator. 11 pi and then divided by 18 is going to be 1.92 inches. And remind me, what did we just find? What's S equal to again? Yeah, Ryan? The arc length, very good. Now, is that all I needed to find? Did it just say, what's the arc length? Oh, what does that mean? What is perimeter? Out of all the sides, right? So when it's talking about this sector, it's talking essentially about a piece of pizza or a piece of pie. So let's draw that real quick. I'm gonna draw my pizza and then I've got my little arc length. We just found that arc length was 1.92. What are the like legs of this pizza? What'd you say?
Sides.
Their sides, good.
Yeah.
What's the measure of those sides? 11. Why is that 11 again? The radius, good, good, good. 11, good. Can you find the perimeter now? Sum them up, right? 11 plus 11 plus 1.92. Perfect. So that 23.92 inches. All right, great work. How are we feeling? Good, all right, let's keep rolling. The next problem is talking about concentric circles of an archery target. When I say concentric circles, do we know what that means? Think about an archery target or a bullseye or darts. Yeah, Megan, what are you thinking? They're all inside each other, so it's a circle with a circle inside with a circle inside, and they're all like equal length away from each other. So like I'll make a bigger circle, and then I'll make a smaller circle inside. And this circle inside should be about the same distance away at all sides. It should be exactly in the middle. Cool, okay, so it says the concentric circles of an archery target are 6 inches apart. Okay, perfect. So I'm gonna label one of these distances away from each other as 6 inches. So they're 6 inches apart. The inner circle has a perimeter of 37.7 inches. What's another name for perimeter of a circle? Circumference. Do you remember the equation for circumference? Good, 2 pi r. In alpha, I reminded them that area, because sometimes in our head, we have like both the little circle formulas and you're like, which one's which? Area is pi r squared. And I remember that area is always in units squared, which is why it has a square in its formula. So if you're like thinking, which one do I use? You want the one that's not squared. Circumference is not squared. Okay, so that's the same thing as perimeter. So we're going to use that. And then it says, what's the perimeter of the next circle? Okay, well, if we have perimeter of the first circle, what's that going to help me find of that first circle? Yeah, Maggie. Radius, very good. So if I know the circumference is 37.7, I'm going to plug that in for my C and I can find R really easily from that. 37.7 equals 2 pi R. How do we find that R? Divide by 2 pi. Just get rid of everything. I know pi feels like a letter, but it's a number. I'm just going to easily divide by 2 pi. And again, if you're going to do it all in one step, throw some parentheses around that 2 pi. So it divides by both of them. And that gives me right about 6. I'm not even going to round that anything differently. I'm going to say R equals 6. If I go to my new picture, that means I can draw a radius anywhere in my circle and it's 6 inches. You know, it would be a fun place to put it next to this label that I already have. So that's 6. The distance between these two circles is 6. And now I need to find the perimeter of the next circle. If I want to find that perimeter, I need the radius. What is the radius of that bigger circle? 12. Why is it 12? Remember, these concentric circles are the same distance around each other. They have the exact same middle, the same center. So I want 6 plus the other 6 to go one more kind of jump out. So my radius for this big one is going to be 12. And that's like geometry stuff. We can find circumference of a circle that has a radius of 12. Circumference equals 2 pi times 12. circumference is 24 pi. Which if you asked me to make something that was 24 pi circumference, I'd be like, that doesn't mean anything, so let's make it have some value. 24 pi is 75 point, we'll just round it to 75.4. And what is that, inches? Yes. Cool, that wasn't too crazy, was it? Oh, awesome, all right. Okay, now we're gonna do some bearing problems, we're gonna do some compass work. I don't need my calculator right now. Have you guys know what compasses are, right?
Yeah.
I'm sure we haven't really used them a lot. Yeah, I don't really use it a lot either. However, the cool thing about this is it's gonna get into like the angles that we're gonna be dealing with later. So when we read these compasses, we're always gonna start at north and then we're gonna rotate around this way to figure out how many degrees it takes us to get to the next measurement, okay? So the first one is we wanna go from north to northeast. So I wanna know what is my angle measurement to go there? Anybody have any thoughts? What is it to go from north to south? How many degrees would that be? 180, that's a full straight line. North to south is 180. What about from north to east? 90?
45.
Good, 45. It's just right in the middle, 45. Okay, now we're gonna go even less. Now we're gonna go to northeast. So now we're gonna go an even smaller angle. Andrew,
22.5.
how'd you do that? Good, just like when I led you to north and east, you said that's 90 and we wanted half of that, so you did 45. Half of 45 is going to be 22.5. That's how much it is from north to northeast. I'm gonna do the last one up here, west, southwest. There's a couple different ways I think of that. So west, southwest is all the way over here. I don't even need the exact number right now, but who has like a way that they're thinking about it? Yeah, Megan, what's one way you're thinking?
West minus 2.5.
Good, so Megan's like, if I know how far it is from north to west, and then I'm gonna minus 22.5, because we know this tiny little increment is 22.5. Does anyone know what it is from north to west? 270, good. 3 different 90s, so that's gonna be 270, so we could do 270 minus 22.5. Which I believe is 247.5. Good, so Megan took the bigger and then minus a little bit off. Who has another idea of what we could do? Yeah, Ryan?
I just said like 180 plus 45 plus twice 2.5.
Good, I love that. Ryan went from north to south, so he was like, that's 180. Then he went from south to southwest, which he knows is 45. And then he went from southwest to west southwest, which was 22.5. So 180 plus 45 plus 22.5. I'm gonna argue that's the exact same answer as 247.5. So the fun thing about that is we can see, you can build up, you can break it back down. Several different ways you can do that. Okay. All right, moving on. Let's do a little bearing. We're gonna do a little drawing on letter E. It says sketch the diagram of the ship on the given course. We're always gonna start north when we're doing this navigation, this bearing stuff. And then again, we're gonna travel this direction and we're just gonna put a line where it's 35 degrees. You don't have a protractor, so I don't need it exactly but we're gonna make our best guess. So if I'm going this way, is 35 degrees gonna still be in the first quadrant? Is it gonna go all the way down to the fourth, to the third, to the second? Where is it gonna be? Just in the first, right? Just like a tiny bit over here, right about there is probably 35 degrees, right? And because we don't have protractors, I want you to label it. I want you to say this is 35 degrees. Tell me what you think it is. Okay. The next one says 128. Which quadrant should we be there? No, it's not gonna be in the second quadrant.
The one that's like
The fourth quadrant, good. We're gonna move another quadrant, but the second quadrant is technically over here. We're gonna go all the way past 90 and a little bit more, so we're gonna be down here in the fourth quadrant. And that's 128. Yep, the second quadrant we would travel to, yep, but that is the fourth. And then the last one is 310. We've not really dealt with angles this big, but get ready, we're gonna do this a little bit more. 310. Is that past this east line? Is it past south? Is it past west? Is it all the way to north again?
No.
Nope, it's somewhere in here in the second quadrant, okay? And I can make that just one full line. I'm gonna come all the way down here and stop right about there. Here's my line. And I'm gonna label that 310. Alright. You guys are doing great. I've got one more problem I wanna do. I know we got 5 minutes left, but I got one more problem. We're gonna skip letter F. If I decide I wanna do that, we'll do it tomorrow. If I don't, we won't ever see it again. All right, this problem we are navigating, we're kind of combining all the things we've done today, which is why I'm kind of like fighting to get here. It's talking about two boats. One of the boats is traveling at a bearing of 42 degrees and 32 minutes. That's this boat right here. It left the Cape the exact same time this other boat that's traveling at a bearing of 52 degrees and 12 minutes left. And we want to know after 25 miles, how far apart they're going to be from each other. That's going to be an arc length because there's a curved line when we're doing those bearings. So we're looking at arc length. And so what I want to do is I want to find the arc length of the yellow guy. I want to find the arc length of the purple one, and I want to minus the difference between them to find this tiny bit right here. Okay. Arc length formula, S equals theta R. We're going to have to do two of these because we've got two boats, right? However, R is the same in both of them. What's my radius or my distance away from where we started? 25 miles, good. Now, the theta is going to be different based on the yellow or the purple. Let's work smarter, not harder, okay? Boys, why don't you find the yellow one? Can you do arc length of the yellow one? Remember, my theta must be in radians, so you need to make this degrees, minutes, seconds into a decimal and into a radian, and then plug it in. Girls, I want you to do the same thing for the purple one, okay? So again, we take our angle, and we got to make it into degrees or to decimal form first. Make it into degrees, make it into a decimal, and then multiply by pi over 180. Boys, I found your decimal degree. Now I'm gonna make it into a radian. Okay, so I got both my answers so far. So girls check your work, I got 22.78. Boys check your work, I got 18.55. The last thing we do is just minus them from each other.
Why is it? No, not that.
So the final answer is 4.23 miles. Now, I will ask you to do all those skills separately, but I will not have a problem like that on the quiz. So all those skills are important. That's why I really rushed to get it done. You will not do a problem just like that on the quiz though, okay? Cool? No homework. See you for a quiz tomorrow. And please.